My name is Ljiljana Trajković. I'm a professor here at SFU. I'm also chair of the Circuits and Systems Society chapter, and this talk is sponsored by the chapter and of course by the IEEE Vancouver section. I have some housekeeping items. That's the first thing. And as I mentioned, this talk is recorded and it will be posted on the webpage, Vancouver section, and we also maintain our local. So I would like to introduce Dr. Elgendi. He's a senior IEEE member and currently a Mining for Miracles postdoctoral fellow at University of British Columbia. In addition to his 10 years plus experience in the field of data analysis, he also received training on big data analysis and leadership in education from MIT. Dr. Elgendi's experience in the area of data analysis and visualization includes his work on global health with Preempt Initiative that was funded by Bill and Melinda Gates Foundation and the Institute for Medical Innovation at Nanyang Technological University from Singapore. Dr. Elgendi specializes in bringing the areas of engineering, computer science, psychology, neuroscience, and medicine for knowledge translation. And as I mentioned, this talk is sponsored by Circuits and Systems Society, and the title of the talk is Basic Tips and Tricks for Data Visualization. I would like you to welcome Dr. Elgendi. And we look forward to it.
Thank you for coming today, and thank you, Ljiljana, for putting this together and for your kind invitation and warm hospitality. Today I'm going to speak about data visualization, and today there is nothing about math and programming. It's just basics. And I hope that you're gonna like what I'm gonna talk about. As Ljiljana mentioned, I work in different departments, and that's why I'm presenting today on data visualization. I'm gonna share these steps with you guys. What is data visualization? There are many definitions, but mainly it is a representation and presentation that amplify cognition. So something that you simplify a complex data, complex scenarios, to amplify some cognition from what you have. Let's go back in time and imagine that we are 5,000 years ago in the middle of a desert and looking at the biggest data ever we have. This is the first thing that a human being has seen, and there are many things that we can think about here. And if I ask you guys, how can we make sense? How can we amplify cognition from what we see here? What will be the best approach? What can we do with this data?
Gaze at it.
I would organize it into some sort of critter or asterism.
Absolutely. So likely you're going to look at sort of like looking at distances between the stars and the blooming points and try to make sense. Perhaps you look for patterns and to correlate these patterns with something with our environment, with what we live here on Earth, and correlate what's happening up there with us. And we can find some patterns, and we call them Leo, and correlate that with traits. We correlate that with our environmental changes. That's absolutely phenomenal. And how about I show you guys here what the Egyptians 5,000 years ago did in terms of data visualization. That was primitive, but you will be very impressed on the way they visualized this. Very complex, and you have the image in your head. But let's see what they've done. This is 5,000 years ago. And this person right here is Isis. She's the Queen of Egypt. She's at the top of the ladder. There is nothing else. She is the queen. And that's her husband. And that's her son, Horus. And they presented the queen with the highest intensity of the star. So that star right there is with high intensity. And he is the second in terms of intensity, and Horus was the lowest, and he's copy and pasted because that star is the same intensity of that star, And then you have a phoenix, because that bird comes in the darkness, and it represents or resembles a fixed point, pretty much. It's you can see it in the morning and you see it in the nighttime, so that's like a fixed point, same intensity, the highest, second highest. Unbelievable. So they looked at the stars and they started to see some combination of some stars together and make sense of these stars. This constellation, they looked at it at a particular time, because they change, right? Some of them change. So that the time stamp was right here. If we're going to say 24th or the 3rd of March 2017, here's the 3rd of March 2017. 8 months of winter, followed by 4 months of summer, and that particular time, we looked at the sky. This is the time when the crocodiles start populating. What a beautiful time stamp for the constellation and the use of intensity to data visualize a very complex system. Very interesting. It is something in our blood, something in us to simplify and data visualize. So what is required? Well, the required tools, skills, and these tools and skills are non-intuitive in the sense that we need to learn them to do them systematically to visualize data. Sometimes it's hard to program them, but if you learn how, it's going to be fine. The good news is the human brain is very powerful, and we are very good with recognizing patterns and shapes. That's in us. That's how we do it. And the communication between the eye and the brain is so fast. And the saying of one look is worth 1,000 words, it's actually kind of correct. But I don't know who came up with that saying. Why one look is worth of 1,000 words? I tried to dig down to find out when that saying started to be, where. And the reference was in 1911 in a newspaper in New York. This is the beginning of saying like one look is worth 1,000 words. But I still don't know why 1,000. Why just 100? Why not just 10 or a few? Or like, why worth of 1,000 words in 1911? You came up with this. And today we're gonna quantify that number right now together. The first study I'm gonna look at is a study which is an invasive study, and that study was done on a guinea pig, right? So they put a microarray in the brain, and they start showing some photos and looking at the firing of the neurons, and they found that the response of the neurons is about 10 megabits per second for firing each image. And that was very interesting. If I ask you now, that study, by the way, done in 2006 in Pennsylvania, and if I ask you how fast you can read, you're going to say, perhaps I can read 300 words per minute. That's, I can read so fast, perhaps. And if I assume, following that logic, if we represent the words in our brain by 32 bits, for example, that comes to 160 bits per second if we speak about the speed of reading. If you want to compare one image, an image actually has 62,500 words according to the assumptions and the hypothesis and the study that I just discussed with you. One image, 62,000 for that invasive method. There is another study from MIT published 2 years ago to the speed of seeing an image. That's like priming. I show you an image very fast in 16 milliseconds, and then I ask you, did you see something in there, like a flower? Did you see a flower in the image? And you say, yes, I've seen. And 60 milliseconds, when you do the math, it's about 1.5 megabits per second to recognize a pattern in an image. Following the same assumptions, of presenting words, one image is about 10,000 words, non-invasively. So in other words, in 1911, one look is worth 1,000. In 2017, we can say one look is worth more than 10,000, at least 10,000, according to the non-invasive study. So that's how powerful the image is, or the figure that you are presenting. We are not wired to read fast. We are wired to visualize fast. That is for sure. There are data visualization awesome tools when it's used effectively. There are 4 fundamental data visualization. Why we do data visualization? One is to analyze, and we know that. If I have a bar chart, I can analyze bar chart, heat maps, bullet, line graphs. I can analyze data from this chart, and I analyze them for what? To look for trends, look for patterns, and make some decision, right, based on the figure that I'm seeing right now. That is arguably the most famous figure for 2016. And the reason is, can anybody tell me why it is arguably the most famous one? The 9th of November, a candidate went within 2 hours from losing to winning. So what happened exactly within these 2 hours? This is a data visualization. It's a figure. It's a line figure. Very simple, basic, and clear. And sends the message that you want to tell. So you start analyzing. We have data visualization to discover. And this is by combining. If I'm looking at different data sets at the same time, and I'm trying to combine 2 different data sets, following the previous example, I have that figure that I just analyzed, and I'm going to get a data set completely different, which is the Mexican pesos per US dollar, for example. And I'm looking at the correlation and causality at that particular time, what happened here. So you combine 2 different data sets, looking at 3 different data sets, or 4, to discover some causalities and correlation in your work. To tell a story without even writing a sentence. You can tell a story without even writing a sentence. And I'm going to show you that beautiful figure, also published last year, almost end of last year. Very powerful figure. It's about the healthcare expenditure per citizen and life expectancy per citizen. What is interesting? You see a country like USA spending about $9,000 per citizen, and the average life expectancy is about 79 years old. Where a country like Chile spending about $1,000, but they're achieving 82 years old of age. Again, we can sit here and we can write stories about this. Lifestyles, 2, 3, 4 pages easily. The beauty about that figure is the normalized data. So they take, so as you see here, 1970, and at the end of the line is 2014. For each country, the end is 2014, the beginning is 1970. So it is normalized by the duration, which is interesting. Because usually that's not being done. Like usually you put it as a bubble, and the bubble is increasing or decreasing, and you have an animation for that. That figure is like, you don't need to do animation. I can give you everything in one figure. And you look at Japan, you look at... We visualize data to teach. And that is, I'm going to show you how, that figure, for example, that figure is created for teaching. There is no other way. And the reason is giving you the dynamics and the mechanics of a heart, of the systolic pressure and diastolic pressure. And it explains the mechanics of the left ventricle. every clinician will have that figure in his head or her head while they are working. There are figures in their minds, and these figures stuck all the time, and they refer to. These are the standards. And usually a figure like that is full of arrows describing the cycle, different colors, and showing the mechanism and the dynamic. So what exactly are you producing? You're producing a figure to teach, to analyze, to discover. The common ground in all of these figures is to visually quantify. And to quantify differences, we have 7 attributes. If you want to quantify differences, the basic 7 attributes we use are, I'm going to start with the first one, which is color. And if I ask you guys right now, how many of you think that the saturation of figure B is 2 times bigger than figure A? Please, because this is very important. These are the 20% that's going to make an 80% difference in any figure you produce. What would be? What do you think? The saturation of figure B 2 times bigger than A. How many of you agree to that? Agree? 2 times? 3 times? 4 times?
What is the saturation?
Yes.
Oh,
Hue.
the hue.
The hue, the saturation, the color. In terms of color difference.
I can only see that B is darker than A.
Yeah, but can you quantify that? Like I say, 2 times or 3 times?
Compared to the yellow and red.
You know, the blue looks like
It's not about brightness.
it has a shading, so it looks like it's 3D, therefore it's a bigger void than a flat circle. That's what it looks like.
Right.
Yeah.
It's equal.
Yeah. So it's hard to quantify. I'm going to jump to another attribute. The volume. If I say figure B, many of you think that figure B is 2 times bigger than figure A? 3 times.
2.5.
2.5?
8 times.
8 times.
8 times.
8 times.
Is it fixing?
Please remember, because I'm gonna tell you the answer. How many of you think that figure B is 2 times bigger in terms of area? The area of B greater 2 times bigger than A.
4.
4 times. Okay? Okay. All of you, okay? How many of you, the slope, I'm going to look at the attribute of slope. How many of you think that slope of B 2 times more than A? 3 times. 2. 3. About 3. Angle. 2 times? More than 2? 3? 2? 3, 2? Length.
Twice.
2 times. And you're very confident with that. I like it. It's like, oh, that's twice for sure. There's no doubt about it.
We do bar graphs.
Yes. How about positioning? With scale, I mean. Like, you have sort of references. What will be? It's 2 times, and everyone definitely agrees with that. So, if we look at the attributes and start ranking them down, you'll find that the position is the highest. We have, when you look at positioning or scale, reference to scale or to position, that is the highest. Everyone will get it. Actually, length was easy. Everyone got that. All the figures, figure B was 2 times bigger than figure A in all the examples that we showed. So, angle, yeah, some of you said twice. The slope also was like 2 times and a half, and area was like, I've heard 4, I think. Well, here is 8, I heard, and color was like, I don't know. I don't know. I was like, I can't tell. So, be very, like, it's very sensitive area, and when you have your data and you want to present it, please just take that in your consideration. These are the basics that are going to make a huge difference in the way you present your data. And if it stacks, if that figure, if this slide is, if they just this is what you get from today's presentation. That's enough, because you're gonna know what to do next and how to judge a figure layout. Now, how to choose a chart. This is also, we're gonna have another session for that, maybe within the next 1 month or 2 months, to speak about choosing a chart. But I'm gonna give you a glimpse here. This is from Andrea, Dr. Andrea Andrea Abella. He graduated from Toronto University. He came up with, like, he's a computer scientist, and he said, man, this area is so messy. I'm gonna put a flow chart so everyone can understand what's going on here. And he said, look, I'm gonna describe it in 4 different terms. One is distribution, second is comparison, composition, and relationship and comparison. For the distribution, for sure, you're gonna go for the histogram and some scattering. And for the composition, I'm gonna look at how to do stacking and maybe pi. And if I go for relationship, definitely I'm gonna do scattering and comparison the same. We're gonna have just 1 session on how to do that in an easier way. But this is an idea. If you think in a flow chart, here you go. That may help you. But you may try. Sometimes you need to try with the data and see which one is more effective, describing your data more effectively. I'm going to speak now about single chart. So that's just a number. So if you're working with data and the result of your data is just a single value, just present a single value. Here's the WHO, World Health Organization. They come up with that number. They say it's 352 times more health researchers in high-income countries than in low-income countries. It is simple. They've done some data analysis, and the result is just one value. It is so effective. Oh my God, 352 times. That's enough. You don't need to do more. You don't need to have a pie chart or. But let's have some, let's play a game here. And I'm gonna ask you guys, if we are working all together for the World Health Organization, and we got this result. We have lots of data, and the result was 31% of deaths caused by heart disease and stroke in US. Right? And we are working for this organization, and we want to produce this. We want to let the people know what's happening, and just to raise awareness for such diseases and what we found. What would be the best way to present it, you think?
Yeah, about a third of the deaths in the US are caused by heart disease.
1/3.
Yeah.
Yes. Yes. Just say 1/3. That's What else?
I like pie charts.
Pie chart.
Which are circles.
Yeah, it's okay. Exactly. Very good. You're gonna go to area. An area is not good with. Yes. What else? Yeah. Okay. How about we're gonna see what other organizations did. You guys did your work, and now we're gonna see what others did. Okay. You ready for this? Here's Million Hearts. And the way they presented, they said 1 in 3 deaths. Exactly what he said. 1/3, 1/3. Yes. In the United States, it's caused by cardiovascular disease. But then, then they put an area here to describe it. They said the total American deaths, and then another. So it's an area, and they have another area, and from the tips that areas are not easily to be quantified, and our eyes are. Do you really see that's 1/3? It's really difficult. So that was okay, but here you lost me pretty much, because I have no idea what this is. What is under 65 now? If this is 1/3, what would be that? My eye is limited. And so this is an organization. They're doing a great job, but just we are saying have to be careful with the way we're presenting the data to make it more effective. Here is another organization. It's called San Diego. And they like the pie chart. It's a donut chart, similar, and they present it in this way. It is 1 and 3 deaths, and you have a donut chart. You like it? Yeah? Yeah? Here is watershed health. What do you think of this?
Nice.
Nice. Sends the message. Feel it's okay. How about here? This is Memorial Heart and Vascular Services. Do you like this figure? You like it? What do you like about it? And what?
I can count to 3.
Yeah. You can see that nice figure, 3, yes. 1 over, yeah, out of 3, yes. But then, number one is always correlated with
Trump.
with positive. This is very positive. When you put number 1, I always correlate that. Not just me. I presume everyone in this room. If I can say, "Hey guys, I'm number 1," then you guys, yeah. So it's very positive, and we speak about deaths. So that wasn't a good idea. So. And also here I need to go and read. So that's a nice visual, but too much text. Because, did you read this? I don't think so. You just looked at the images, right? It's very fast to recognize a figure than to read. We know that. How about here, American Medical Association? What do you think if we can improve this figure? Well, what do we do? The green color is always correlated with, and that's all green. Ohio. It's quite that nice, right? You agree? You see, that's clear, and everything is fine. Correlations, yes. That's perfect. That's nice. Okay. Let's move on and go to bar charts. And in a bar chart needs to be clear. If you have some attributes, you have your parameters, just make sure that they are clear. Now, I'm going to ask you, you guys think that we need a bar chart here? You have a single parameter and it is standing, and it is just, and the rest, do you have any idea what's here? This is published, by the way, in 2016. Great work, great researchers, overlooked some of the visuals. So, I don't get it. So, when you have a figure, you have 4 parameters, just emphasize on the parameter that is giving you the value that you're looking for. This is the this is the parameter, the most effective parameter in my study, or correlated with whatever. This is also nice work published 2015. If we can improve that figure, what do we do?
Nobody can read the book.
Exactly, nobody can read this labels. Like, we can't read it. Why you make it hard? It should be clear. And do you like the colors?
Not really.
Not really. And how about you see there is an amplitude shift here. Like this, if you split this in 2 figures, maybe I can actually see what's going on between them, because we can't. They're quite relatively close to each other. So if you cut this out, cut this, zoom in, it's before you produce a data like this. How about here? Also nice work, very nice work in 2015. What is missing here?
What's on the vertical axis?
Exactly! What is in the y-axis? Why, this is like the, yeah, I mean, these are the basics. You don't have a, but by the way, the labels were clear. We have to give them, you know, we have to appreciate that. Also the amplitude, they were a little bit creative with writing the value above each. Okay, we appreciate that, but we don't know what the y-axis is about. Yeah, what is the unit for this? Box plots is to show differences. Bar chart, yes, but box plot even more, because you're considering the mean, deviations, and this is published 2014. That's a box plot that should show some differences. Do you see any differences between all these parameters?
Not significant.
No significance. How about here? This is 2015. If we can improve the figures, what would we suggest? Box plots, we need to show some, if there is a significance, I want to have a p-value that is written above whatever you're comparing with. Because now, I don't know if you're comparing between the first and the last, the first and the second, the first and the third, I don't know. So you need to put here, show me, here's a significance, put a star or p-value equals something. We need to know what you're looking for, where the significance are. We don't know.
What's a p-value?
The test, the result of the t-test, it's a statistical test to show differences and significant differences between two sets. And the p-value is the value that is giving you if it is less than 0.05 or greater than. If it is less than 0.05, then there's significance, it's more than. And usually you look at 0.01 if we very fussy, and so on. But yeah, if it is, so you put p-value less than 0.05 or something, then I can see if there is significance or not. Because yes, I can see difference, but I'm not sure if it is significant enough or not. Yeah, I can see that there is a difference here, but is it like significant? I don't know. I have to dig in the paper in order to get the value. Okay, here's a nice figure, also published in 2012, and there's something funny about that figure. Can anybody?
Log 10 of what?
Yeah, log 10 of what? Thank you. Log 10 of what is the parameter? And that's published. And also, when you look at these two variables, you look at the significance here is less than 0.001. Here the significance less than 0.01. Here, between this and these two parameters, it's less than 0.01. But do you see difference between them? I see overlap.
Yeah, so
Right? This one is overlapped with this one. I don't see that value. That value means it's so significant. There's completely different from each other. And here too. So it's like I don't really know what's happening. Okay. I don't know why this is cutting down here, but this figure is nice, published 2016, and they put the value, p-value 0.02, 0.02, less than 0.001. We appreciate they put the values, but in the bottom right there, they didn't. We don't know the sample size. If you want to put something like, if you want to compare, yes, you found significance, but you have to also let the reader know how many subjects or how many data points in each of these data sets you're comparing with. Now, I don't know, maybe you're comparing 5 with 11, 100, I don't know. So I need to, here is an example. You have 2 parameters. You're looking at normal and tumor, nice. You put a p-value, yes, there is significance. Yes, these 2 data sets are different. Yes, we get it. I can visually see it and statistically read it. Correct? Correct. Now, the number of subjects for that parameter for the normal data set was 5. For the tumor, 40. We appreciate that they put the values, the number of subjects. But we really need to have it in every box plot. Just let us know, because now I can judge it a little bit differently. Here is 5, here is 40. I will see like there's some bias in this calculation. But still, there is an effort being done. You see, figure, easily, clear, to the point. I don't need to dig down. Pie chart. The most famous pie chart, not really, but the second most famous. What is funny about that pie chart?
Brim's killing
Hmm?
Brim's killing, yeah.
Yes! Yes, absolutely. So rim is the blue, is killing apple. However, the presentation, putting it pie chart in a 3D, and putting the sector that of interest on the foreground, or forehead, it makes it look, yeah, it looks more bigger than the one at the back. So for sure he used it for a reason, right? So when you have a pie chart and somebody's sitting or reading it, just put it properly so you don't show that this is the highest result. If you ask me how to present it, or the best way to present a pie chart in this case, because in this case we need a pie chart that works as a histogram. In a way, we want to put them in a descending order. So here is the rim, other, apple, high, low, low. So in a descending order. Then I can judge. I can see you are the third in the rank, right? This is the highest. This is number 1 pie chart. What's wrong with this pie chart?
It's more than 100%.
It's more than 100%. You are sitting at home watching a TV, 2012, and that pie chart came out.
It's rigged.
It's the pie chart is rigged, exactly. So actually it's 100%. Okay, here is another one, interesting one, also published in 2014. And these pie charts, what do you guys think about them?
Too complicated.
Too complicated. It's too complicated. Too much colors in it. For sure you're gonna have data. For sure you have lots of data and you wanna present them. Just present them in a proper way. You need to try now. You need to try to find out a proper way to present your data. And there are many ways to do that. You can't even read the labels. How about this? Published in 2015. And that pie chart, there has something fundamentally wrong with pie chart.
Is it the same color or different?
The color is not a good choice, yes. They didn't choose the color carefully, yes. But there is something fundamental.
So the scale is way off, isn't it?
Yeah. Say it in a different way. What do you?
Well, something that is, the cellular processes is 7 times bigger than the biological ones, but it doesn't look like it's 7 times bigger.
Yeah, that's correct. So the pie chart is about part in a whole, right? So you say 5%, 10%, 20%. Here, these are frequencies. This is not a pie chart. Is it a pie chart? 325, we don't know what these are. So why did he go to that world? I think that wasn't a good choice, right? But there are better ways to do histograms or bar chart, whatever. NASA. This is about a budget, and I'm sure NASA, they have great scientists, but the budget for this project can be presented in a more clear way.
No numbers. It's a
No numbers, thank you. There are no numbers here for the budget, and we don't know how, like how much from, we don't know how many percentage here. This is 10%, 5%. I cannot judge this by eye, just quantify the differences by using colors. We can do that. We already knew that in the tips and tricks, right? Colors is not a good idea. So that was published also last year. It's a very nice pie chart, but there is also, that can be improved if you can propose any improvement. Anybody? Colors, maybe not a good idea with colors. Yes, what else?
Too much text on the left.
Too much text. So is it educational? Is that a visual to teach? I don't think so. Because to teach, you need to have dynamics, mechanism. If you're putting for a pie chart too much text explaining a pie chart, there's something not decent here. A pie chart is a pie chart. You don't need to put a text to explain what's happening. And also ranking them. So when we have a pie chart, please put them in a descending order so we know the differences. These guys are getting pretty much similar areas. Okay. How about here? Published 2014. Labeling. You like the labels? Nice.
Font's a little small.
So much.
Font's too small.
Fonts too small.
The choice of colors is really poor.
Exactly. Because we don't quantify by color. We can't. Yes.
It seems to me that when you got more than 5 or 7 items, it's just
It
not
means
really
like
worth it. Yeah.
exactly. There's no need for the pie chart. You went to the wrong arena here. You need to do something else. How about this figure? 2015.
It follows your suggestion.
Yes. And it is it clear? It is clear, no colors, nothing in it. But it is clear pie chart. I understand what's happening for influenza here, 13 for malaria. I can follow. Maybe the last 3 parameters we didn't mention the value, the percentage, but we appreciate the clarity of the figure. Right? Let's jump into line chart. A line chart, and now we have 4 different lines, and in this chart, is it clear to you? Do you think you can see difference between the lines? Or you,
The red and orange are too close.
yes. So when you have a line chart and there are many overlaps, not a good idea for a line chart to have overlapped lines. Try to find another way. Try harder. That's 2016, by the way. How about this figure? What do you suggest? Exactly what you...
Yeah, expand
The scale, the amplitude. Can you just... How about you move these labels? They are so big. Just move them here and, you know, zoom in so we can see the amplitude and compare the amplitude of all these three. So we see what you're talking about. By the way, you guys know we are engineers. There are many figures like this produced in engineering and all the areas, and it's just the, you know, not a proper choice for the visualized data. So we need to be very careful. Is it clear for you? This is not clear. Too much overlaps, right? We understand this stuff. They are clear. But what's happening here, it's hard to differentiate between, right? So, how about this figure? That's published 2016. Something fundamentally wrong. If we can improve this, what do you suggest?
Use different colors.
Exactly. So you see, have red, red, red. We understand that every red has a different triangle. This is a filled triangle, an empty triangle. I'm not sure this is also an empty triangle. Right? What's going on here? As a data visualist, you have to be very careful with this. Before you produce a figure, just make sure that it is properly describing what you have. So the coloring and also the symbols that you use. How about this figure? That's 2016. All the figures are from high impact journals. All of them. You can differentiate between them, right? Yes, we can differentiate. Very nice, clear, clean. Yes?
I don't like this horizontal line 45 degrees. What's the point of that line?
Exactly. What's the point of that line here?
Slope, maybe?
Slope, or if there is a slope, you have to produce the equation of the slope or the value of beta for that slope. So we have no idea, because now if it is slope and regression, and we're speaking about something that's two different things here. And so there is no need for that line. Scatter. Okay. Here's a scatter. Beautifully done, 2012. A nice figure published. You have lots of data and you put a linear regression here. How can we improve that?
You want the equation of the line.
Thank you.
R value.
We need the equation of that line. Why are you producing something I have no idea? 2.
Color.
Color. Maybe the color is not, perhaps use a different color. 3.
What's the regression coefficient?
Yes, the regression coefficient. What else?
Why the axis labeled 0, 3, 6 and then 6? And
Exactly. There is something with the y-axis and the, but also something fundamentally important.
Title, what is in chart of all about?
Yes, the title for the chart is very important to choose the title, but something important when we present data like this.
Origin.
Huh?
I didn't see the origin.
The
He wants to see the origin.
Yes, that's exactly what we discussed about what happened here, why they missed that part, and what was the origin? Is it 0 and 0, or why they scaled this up? That's correct. There's something important here. Are you going to count this number of points? So why don't you just say the number of points or subjects that it is here in this graph? It's n equal 1,000, 1,200. It's not going to harm you. It's just put it. Just make it clear. How about here? $2,015.
You can't tell between the green and the blue.
You have blue and blue or blue and green at the coloring, and what else? There's an
Empty. There's all these empty stuff around.
an empty, yes, empty space, and there are lots of overlap here. It's hard for us. Is that what you're trying to tell us? There is an overlap here. If you want to show that, you can show it over something else. Again, number of subjects and so on and so on. That's a nice figure. Looks nice and clear. They put the correlation coefficient and the p-value for the slope, that there is a significant difference in the slope. So tell me now, how can we improve that figure? I want to hear two things.
There's the equation of the line
One,
and the number of points.
number of points. I need another one. There is an extra one missing.
Sorry?
Jack, we have an empty circles and black circles, and we don't know. Right? This figure? Scatter. These guys, they put the line, the equation, number of subjects, thank you.
But there's two lines.
There are two lines. Exactly. There are two lines. We don't know. Is that like the confidence interval? Please make it sure. If it is, well, two dot lines, and you have a line of the regress line. The main one and the confidence interval. It seems that they missed a second dot line for the confidence interval. But the other, and also the legends here is like, here's the square is Eastern Rivers, and here's the cross. Still nicer, but another 1 point to make it more clear. Bubble chart. This figure is just published as is, 2013. Just bubbles, without no description. No kidding. This is exactly what. How about here? Here's the. I'm not sure why it is. What's wrong? Oh my God. Okay, so here's the height and the maximum seawall height and tsunami height, and the circle is the destruction rate. So the width of the circle, or the size of the circle, is the destruction rate. The size of the circle here is the death rates, right? So that's like a 3D, but in a nice way. The third D is the size of the bubble, which is a nice idea. But what is wrong here? Can you differentiate? There are too much overlaps. We don't know how to retract this. We appreciate that it's a nice study, everything is nice, it's just the final touch of presenting the data. That's published in Science, and that is a nice relationship between innovation and respect. And the size of the circle is loyalty. You assume that the more innovative people, they will get more respect, and they will be more loyal. Correct? The more innovative, the more respect. That's happening in one company pretty much. Regarding the loyalty, which is the bubble width, we kind of know about the innovation respect. Yes, that seems like this company is a very nice company. They give the nice respect for innovative people. That's nice. These companies, you just don't go there. Okay? But the main point was about loyalty. The whole idea, you see, the width of a bubble is a loyal. So do you think the area was clear enough to show difference between the companies?
I don't see much.
Why? Because they used the area. And the area is not a good idea to show differences. Unless there is a huge difference, then we can sort of like, but here it's relatively close, actually identical. If the article is about loyalty, and how can I? So, data visualization, very important. The tricks and the tips is very important. How about you're looking for frequency? You're looking at text mining, for example, and you went to see the text from males and the text from females, and how frequent the females are using in terms of words, and how frequent males are using in terms of words. We have two clouds here. The more frequent the word, the bigger and bold the word is. So which cloud is male and which cloud is a female cloud? Text coming from the female. The one is male. And here it's like love, that's the most frequent text. The most frequent is shopping, excited, and the smaller the size, the less frequent, and so on. Sometimes you want to use it, and again, when you use it, these are words. So we're going to use them as image, because we don't read fast, right? We already said that. So when you're going to look, you're going to look at the more salient word, and that's it. So when you look at the figure, yes, shopping, excited, you're not going to follow the others, unless you're going to put time. So in the optimal situation, we need to wear multiple hats. And I think we agree, in academia, I think that would be the 8 hats we have. The primary investigator and the data scientist, the machine learning guy or statistician, and then you have a communication specialist who's going to put this to disseminate the results to the locally in the hospital, for example, or in the UBC or SFU, and you have the graphic designer who's going to design the work for you, and the finance manager is going to make sure if this is running under, within the budget, and if it is something related to money, they have to go and also look at your figures, make sure that it is correct. And marketing specialists, these people, you need that hat too. You need someone who comes and say, yes, I can take this result and I can raise money and get more funds for this. And you have the facilitator that can also help you to get students and help you with the writing for your grants, and the project manager as well. And usually the project manager is wearing multiple hats, and the primary investigator also wearing multiple hats. But this is in the optimal scenario. And there are many overlaps between these two guys. The PI here will overlap in terms of the purpose and parameters, and prepare, explore data, formulate conclusion, concept and design, construct lunch. So the PI with the data scientist in 2 phases here, and the communication specialist comes at the conclusion to look at your work, and the graphic designer is taking whatever the conclusion, putting it in a design that is suitable, because they know. The facilitator is also looking at what can be used here to help with students and attract more writing for grants. Marketing specialist taking your design and promoting outside. The project manager is looking at the whole, all phases, and the finance manager as well. In summary, we use data visualization to analyze, to discover, to tell a story. We know that it has 7 fundamental attributes. We've seen that the positioning and length are optimal in terms of attributes. And we know now when we choose a figure, a data visualization chart, we have to make it as clear as possible. Remarks. We went today through 25 scientific articles, and we went also through 10 organizations. If we assume that you have 5 authors for each of these, for each article or each organization output, and 3 reviewers and 1 editor, that ends up in 315 researchers overlooked their data. That's why it's very important to speak about this. 315 just right now, randomly. I think if we put more time, you will be surprised with the results. We're going to have part 2 about the programs to use and hands-on the examples and real-time visualization development. And feedback, please let me know your feedback, and thank you, and let's keep in touch.
Thank you very much.
Appreciate it.
Okay, now we can answer some questions.
Any question?
We also hear refreshments in the back, so that's along the lines when you ask questions, you can also do that. No questions? I thought your chart at the end with the managers and PIs, it was very nice and so you actually practice what you preach.
What's your background? Are you more like a technical or medical?
I'm a biomedical engineer.
Biomedical?
Yes. So during my path, I started as a computer engineer, and then when I went to Australia, I worked as started to learn about biomedical applications, working with the hospitals and firefighter centers to collect data, ECG and pulse oximetry. And that's why I work with sort of clinicians and engineers, and also I want to satisfy the curiosity when I show a figure to two different people coming from two different backgrounds. When I went to Singapore, I worked with psychology department, working in subliminal priming, showing images and text very fast to see how the brain react to that, if that can bias your decision later on or not. And so that's how I also worked with psychology. Alzheimer's disease, brain activities. And then I went to Alberta, was still working with clinicians on heart sounds, and I moved here and I'm working with pregnant women, a hypertensive pregnant woman at BC Children's Hospital. And that's what my fellowship is about.
Any more questions? Well, let's thank Mohamed again.
I really appreciate your time, and your feedback will be so valuable for me.
And he will come back. I also would like to thank Bill Lowe from the Vancouver section for taking the time and effort in order to video record. And I want to thank Helen for bringing the goodies, so please help yourself. She's my helper with the CASA. So thank you all for coming.
When do you think part 2 is going to be due?
We didn't schedule it in a month,
Oh.
month and a half. I think before summer.
Yep, sooner the better. It sounds very interesting.
Good.
So, Mohamed, you got
Nice. Good feedback.
At least one thumbs up.
At least we got one person.
and we'll do it probably Friday at the same time. So thank you all for coming.
Winner.